Let's review the cost diagram and reduction formula. So first of all, when you are going to do trigonometry, we always expect you to draw this little plus Cartesian and to fill in the details. What details do we need? First of all, you're going to name it, and you are naming it cost starting in quadrant 4 going counterclockwise, CAST, and that stands for cos, all, sine, and tan. The labels that we're putting in is referring to which angles are positive in that quadrant. In quadrant 1, all angles are positive. In quadrant 2, only sine is positive. That means that cos and tan are negative there. Quadrant 3, tan is positive, sine and cos is negative. And quadrant 4, cos is positive, sine and tan are negative. First things first, you are going to do the shape. And then the second thing you're going to input is your cost label. Next up, we are going to label our axis. So when we are going to label the axis, I want you to notice that you're going to start on the far right. This is your x-axis. So whenever you place your protractor is going to be in the center here, and this is going to be 0 degrees. 0 degrees, and then straight up over here is 90 degrees. On the far left, you are going to have your 180 degrees. At the bottom, it's 270 degrees. And then the 0 degrees has a second angle. It is also 360 degrees. So you are going to label from 0 to 360 degrees, all 4 angles, 5 labels. Okay, so far so good. So next up, we want to basically do reduction. Reduction formula has to do with how to simplify an angle. So if I give you a really big angle, you can simplify it to special angles using the reduction formula. So let's first start with our big ones. So over here, we have 0 and 360. Over here, we have 180. So first things first, if I have an angle in this quadrant, this is simply an acute angle known as theta. So theta, I don't do anything to it. I can use it as sine of theta, for example. No problem with that. But what happens if I have the same angle over here? If I have theta over here versus having theta over here, or having theta over here. Let's assume theta is all the same signs, right? So how do I solve that using the reduction formula? So the first thing I want you to notice is, remember, we're just using the x-axis at the moment. Using the x-axis, we can say in quadrant 1, it's sine of theta. In quadrant 2, it's actually 180 degrees minus theta, if that makes sense to you. So instead of just putting theta down, I'm now going to label this as 180 minus theta. Whereas this one is 180 plus theta. So that makes sense to you, 180 plus theta, right? And then our third one is 360, go back theta, so that over there is going to be 360 degrees minus theta. So those are going to be our 4 reduction identities, or not an identity, reduction formula for the x-axis. We also have reduction for the y-axis. So if we're using that 90 and that 270 degrees, if you look at theta over here, starting at 90 degrees, we can then subtract a value, but it won't be this theta, it would be that. Let's make it alpha. If you subtract alpha over there, whereas going this way, we would then be adding alpha, if that makes sense. So on the x-axis, what these angles then become is, okay, let's leave that pink theta there. What these angles become is, over here, you're going to have 90 degrees minus theta. Please remember, it's not the same. It's not this angle, but it's 90 degrees minus theta on the right-hand side. And on the left-hand side, we're going to have 90 degrees plus theta. At the bottom, you are going to have 270 going this way, subtraction, so 270 degrees minus theta. And on the right, you are going to have 270 degrees plus theta. Now, these are perfectly fine. First of all, what we've done right now we've got done the shape, we've done the cast, and then we've done the axis, right? The fourth thing that we now did was we did our reduction formula, and we looked at the x-axis, which is our 3/6, or let's say 1/81st. Oh, where am I now? Sorry. So our first one is 180 and 360, and then we also did our y-axis, which is going to be 90 and 270 degrees. Okay, so far so good. The other thing that I need you to know is that when we are doing the 90 and the 270 degrees and we do the reduction, so on the pink ones, if we're going to use the pink ones for reduction, the sign of the trig changes, but the trig identity does not change. So if it is cos, it remains cos. If it's tan, it remains tan. But if you are going to use the orange ones, then you are going to swap. So if you are using sine, it becomes cos, and cos becomes sine. If you use sine, it becomes cos, and cos becomes sine. If you are using sine, it becomes cos, and if you're using cos, it becomes sine. For all of these, please remember this. So again, this reduction cos diagram is something that you need to be able to produce from memory without much stimulation. Just quickly pop it out straight from memory. Please work very hard at memorizing this. Next thing, I'm going to continue with my revision. Next thing, I'm going to look at our identities, but I'm going to do a separate video just on some questions on how to use the reduction, just to refresh you. So just look around for that as well, please.